For our agenda, we will start with Dave Cheney, and he'll give an what's new in Go 1.14. Who's here? Who's used 1.14? Who's switched to 1.14? Okay, I too have switched to 1.14. Okay, and then after that we'll have a 10 or 15-minute break. Go eat more food, and then we'll have Kelsey talk about. Surprise. Surprise. Something along the lines of the philosophy of Go, I think. I hope. All right. So without any further ado, let's welcome Dave.
I asked Chewy, how long do I have? And he said, Bleh. Okay, let's just embiggen this a little bit more. So in homage to the man who introduced me to ASCII Doc, I'm not using the present tool because that shits off everybody on Hack and Use whenever they're like, it doesn't work, I can't work on my mobile phone. So I've written a document, which you can find. I posted the links in the Meetup page. So, a couple of years ago, I wanted to do a Go release party, and this is when I was working Canonical. Release parties were the thing, you celebrate, we did all this work. Now we're going to kind of celebrate that we did this work. And the twist that I'd like to take on it was, to take the release notes that other people had and put examples in there so you could actually kind of see what you're getting, rather than just like, here's a wall of text, you actually see what you're getting. Go 1.14 was released, thank God. For a long time this was like on the 20th of February, but it actually got out last month. Part of the reason for this we'll get back to was to do with the asynchronous Go routine preemption, which we'll talk about a little bit later. But Go 1.14 is out. I figured out how to embed tweets into this thing as well, which is awesome. All of this stuff that Brad talked about 6 months ago actually happened. We got all this stuff. We're going to talk about it this evening, and including actually a few bonuses. Some of which I have examples for, others which I couldn't make work. So let's get the usual stuff out of the way. Not a great deal has happened. I mean, I apologize if I'm downplaying something that somebody worked hard on, but it just kind of feels to me that compared to Go 1.2 and Go 1.3, when we're adding new platforms and new operating systems all the time, things have kind of settled down. This is the last release that's going to run on El Capitan. I can't remember which version of that is. I don't know if anyone's got any Macs still running that. Maybe if you're still rocking one of the old non-touch bar Macs. This isn't really something in the control of the Go team. Apple doesn't support its old operating systems, and kind of you're a bit screwed if you try and run code on them. Also, no 32-bit binaries, so just like me, if your copy of GTA San Andreas doesn't work on new OS X, neither is your Go binaries either, so that's a bit of a shitter. But on the plus side, RISC-V support is coming along nicely. It's actually in there. You can use Go OS Linux, Go Arch RISC-64 and actually produce a binary for that. Under construction.gif, expect a few roadblocks, but try it, give feedback, raise issues. Joel Singh seems to be the person who's doing most of the pushing and actually getting the bits upstreamed, so that's awesome. Language changes. It's been a while since the language has changed or been added to, because we don't take things away. This is something that Robert Griesmer pushed through, his overlapping interfaces proposal, which is basically, if you were to do something like this in Go 1.13 or earlier, this seems fairly straightforward. Like, we know a read closer is composed of a thing that has a read method and a close method, and a write closer is a thing that has a write method and a close method. So those two close methods, like in our heads, like if you take the set of the methods on an interface, well, that should be fine. But it turns out you can't do this for a reason which Robert goes into in his document. And apparently in Go 1.14, this was supposed to be fixed, except it doesn't seem to work. This isn't a joke. Like, I'm not sure why I can't make this work, but this is specifically why this feature was added. So there should no longer be a duplicate because its close is specified twice, kind of in the inheritance kind of path of the interface. So I kind of figured this out trying to write an example on the train. I'm going to have to go and talk to Robert and find out why I can't make this example work. But take a quick look at this document, which is the proposal. Oops. You read it yourself. Modules. We're now deep into the modules journey. Continues to improve support for modules in kind of like this general grab bag of, as people are giving feedback to the Go team, especially John and two other people whose names I'm blanking on at the moment, they're fixing a lot of the rough edges. I still think there's quite a few there, and mainly kind of some kind of impedance mismatches between how the real world works and how some people on the Go team think the world works, but it's getting better. A few things that have happened kind of in the last year was that we now have proxy.golang.org, and I believe there's actually a version in China, proxygolang.cn or something like that, which is a module proxy. If you're used to like RubyGems or Maven hosting, this is a facility provided for all Go users to download their modules from, so you no longer have to go to GitHub and schlep that source and do that thing with, what is it, net.netrc so that GitHub doesn't rate limit you. Like, this is a place where it actually goes and downloads the source. It's even baked into Go 113. You can turn it off if you like, but by default it's baked into Go 113. The Go team also stood up package.go.dev, which is kind of a more enterprise version of friendly version of Gary Bird's beloved Godoc. I'm sure everyone's seen that. Package.go.dev has some visibility issues because of an abundance of caution, lawyers are a bit picky about which projects they will render. This is kind of because they believe they're hosting the code by showing it to you, which is their interpretation. Hopefully by the time this presentation occurs, Russ has committed to writing an explanation for why this actually is. Unfortunately, his footnote says it hasn't happened yet. Hopefully it will happen soon. But much better news is the Go team have committed to open sourcing the code behind package.go.dev. So it's no longer this secret, bizarre, opaque blob right in the middle of a project that's been open source for 12 years. So that's good news. Hopefully that'll happen soon. Vendoring support now works better, including if you like to use modules, then use gomod download to keep your own /vendor copy, and maybe you want to check that in or something else like that. The Go tool actually now keeps a little manifest file inside your vendor directory, so it can basically make sure that what's in your go.mod and what's kind of you checked into your vendor directory in your source code is still in sync. This incompatible version thing blows my mind. I can honestly not explain to you the rules. But if you basically go and look in your go.mod file, and if you find things with .incompatible, expect to get screwed on them, because the best explanation I can figure out is that it was a mistake. The rules around how incompatible versions work, like if you're from a Maven world, you might be thinking this is kind of like -snapshot. It's sort of not really. I've linked to an issue where Brian gave some explanation, but your guess is as good as mine. Just be very, very careful if you have things with plus incompatible in your go.mod file, because, well, shit broke for me on my project. Anyway, moving on. The runtime changes. Some good, tasty optimizations. Defer is not slow. Defer wasn't slow before, and it still isn't slow now. But the good news is that it's even less slow than it wasn't before. So, if you think defer is slow now, write a benchmark or shut up. Specifically, the defers that we all use, like what we call the simple defer, like this one, which is not closing over any variables, not kind of giant function that calls other functions that might need state or something like that, just simple defer mutex unlock, now effectively costs the same as doing it this way. Don't take my word for it. Let's run this benchmark. This is just off this machine this afternoon. So old time is 113, new time is 114. So 13.9 nanoseconds plus or minus 2% versus 15.1 plus or minus 4%. So they're not the same. I fully admit that they are not the same. It is demonstrable that this is slower than that. It is a larger number. But if you think defer is too slow because you're worrying about a nanosecond for an uncontended mutex, you can click on that link and watch it yourself. Seriously, there is no justification now for not using defer as a matter of principle. Don't let people be like, oh, defer is slow, you should use atomics, not mutexes. Write code that is maintainable rather than twisting yourself around a pole to make it for illusory performance goblins. There's a great graph by this person who's actually gone all the way back to 1.4 and traced it. And yeah, it used to be because defer, if you wanted to defer a function, you actually were deferring the closure of all the things that had happened up until that point. This at least took an allocation. You at least needed places to put it. So over time, the Go team have whittled that away, isolated the default cases from the special cases and made the default cases much faster. And the results speak for themselves. So, jolly good. Jana has a great blog post about this as well. You can follow that as well. Any Seago users in the house? Yes. Have you? Yes. So, there are a bunch of rules about how unsafe pointers can be used. When I say a bunch, there's a lot. There's a lot of rules about how unsafe pointers should be used. So it's fair to say anyone who's using unsafe pointer to do anything mildly tricky is probably using it incorrectly. And so just like we have a few kind of runtime checks like the concurrent map mutation one and things like that, there is a check which is enabled in race mode which tries to find some of these use cases of unsafe pointers. I wasn't able to come up with a simple example that I could show you, but you can imagine that the program barfs and says, you've done something wrong. But if you have heavy use of unsafe pointer or you're kind of in that Seago world where you have to do a lot of schlepping of data around, especially like you're kind of casting things from C memory into Go types, it's important to click on this, read a little bit more about that. I was not able to come up with a simple example of this, even kind of like copying the, there are a bunch of like, do this, don't do that kind of. So there are kind of a bunch of do this and but don't do that kind of cases, but trying to make up a test case for them, I couldn't seem to make it work.
Go run the race version versus the build version of checkpointer behaves differently. I have the issue. I've still not finished writing the issue. There's a difference in the behaviors of race and build.
Okay, I'll talk to you afterwards. Maybe we can have an example that people can run to see actually what breaks. I always like to have examples. The big change here is what is called asynchronous coroutine preemption. We all know that since 1.5, Rick and Austin have been working to drive down GC pause times. Everyone's seen that series of tweets where it goes down by 2 orders of magnitude. It's pretty awesome. The truth of all garbage collectors is they all stop the world, including what is it, Oracle's non-stop collector, including the Azure collector. They all stop the world. They just do it for a tiny amount, so to the point that where the stopping isn't actually the important part, or the time the world is stopped isn't part. They just need all the coroutines effectively to get to a place, so they can do a little bookkeeping, and then they can move on. And it's come to the point that the actual time it takes to stop the world, to get all the coroutines to a stopped point, has become like, when you take several orders of magnitude out of your GC pause times, this is actually floating to the top. And so work that Austin, Rick, David, Chase have been doing is to talk about how they can make coroutines preemptible. We all know coroutines aren't preemptible. Like if you write a for loop with nothing in it, you know that just stops the coroutine, it will never come home. But what if you could? And this is the thing that they've been working on. So as I said, the remaining source of latency is essentially waiting for coroutines to hit this thing called a safe point. If you have background with Java uses the word save point as well. And it's basically a point where you know that no other thread or coroutine in the program is running. You can do a little bookkeeping, and then you can set them all running again. Now, before Go 1.14, there was some support for preemption, and it was done through stack growing. Everyone knows that if each coroutine at the entry to each function knows how much stack it requires. Like, I need 100 bytes to run this function. There's a little check at the top of every function that says, do I have this much? If not, it kind of traps into this slow path, goes and grows its stack, comes back to the top, checks again, everything's good. And a neat little trick that the garbage collector did is that when it needed to stop a coroutine, it would just reach into memory and set its stack size to 0. So that check would fail, it would immediately trap into the next function call, it would immediately trap into the runtime. It could grab it there and say, just wait a second, you don't actually need more memory, we're just doing some garbage collection bookkeeping. But the problem is, what if your coroutine never makes any function calls? I mean, the canonical example is like for curly brace. But this isn't as unlikely as you might imagine. Like, inlining code, both manually and through the compiler, loop unrolling, are all strategies we use to reduce the cost of function calls. So there's kind of like competing forces. Compilers and code authors are trying to, in the hot path, remove function calls. But at the same time, we need this for the GC to be able to stop a coroutine promptly. So there's a problem. Now, there's a bunch of ways that again, this is not unique to Go. Java, and I'm assuming I don't know how .NET does it, but in Java, the way they do is they put these things called save points all the way through the compiled code. So it's effectively a check to say, should I stop? And you want to put them frequently because if there's a large gap between them, that's latency. The way that I believe the JVM does it is it actually inserts, like you want this check to be incredibly cheap. Like, you really probably don't even want an if, because that's a branch, that takes up your branch condition, you have to predict it. It's kind of, you don't want this. The way that I believe the JVM does it is that they read from a page in memory. They just insert these kind of like dummy reads, just go and read this variable from a page in memory. Because don't forget, in the JVM, you have tens, hundreds, thousands of threads. That's normal. So they have all these threads just checking to see if they can read from a page in memory. And then when they want to stop them, they unmap the page. All of them get a sig fault, trap into the runtime, and they go, you got a memory error because actually we wanted you to stop. Thank you for coming and telling us this. Now in Go, we kind of have some. David Chase did look at things like this, that kind of approach, but what they've kind of settled on is a much simpler approach. That we might have tens or thousands or millions of coroutines running, but we only actually have a few dozen at most threads actually running. So there might be a lot of runnable coroutines, but the ones actually executing, the ones you have to stop, are measured in dozens. So for those, and we know where they are because those are the threads that the Go program has started. So we just send them a signal. Good old signal. The design document at the bottom here goes into, well, which signals should we choose? We shouldn't fight with people for their signal handlers, things like that. And it turns out this is, as Goers want to do it, has shown up a few kind of kernel bugs in various operating systems which have been worked around. But it seems to working okay. That kernel bug and the fix was some of the reason why Go 1.14 was delayed for some time. In case you don't know, when they cut the first release candidate, or it might be I think it's the first release candidate that gets made the default inside Google, and they just compile everything with that. And so we have the Benevolent Alphabet Corporation dogfooding their own software for us. So it's great that they find the bugs before we do. But that was the reason why, one of the reasons why the release was delayed. What does this mean for you as Go programmers? Perhaps not compiler otaku or like nerds who really geek out on this. Probably not enough. Probably not much, but it just means that the Go team are keeping driving the GC cost down, because that's the difference between a process that's crashed and one that isn't getting back to you because it's doing a garbage collection cycle is kind of academic. So if you drive down your GC latencies, you drive down your tail latencies for servicing requests. That's the name of the game. A new member, Michael Kay, a new member to the Go team, has been working on allocator changes. You should read the proposal. I'm sorry, I don't have all the details, and I'm not even going to speculate, other than they certainly improved, especially around the scavenger, which really hadn't been touched for 8-9 years, something like that. So that the scavenger, I believe the scavenger is now, rather than kind of on a fixed timer, it actually kind of is demand timed. Like if it only runs if it thinks there's actually memory to scavenge. So if your heap hasn't grown, well, there's nothing to scavenge. So just to make it more efficient. And something that Ian was working on, I think this might have even been held over from 1.13, was that timers, the internal timer code, now behaves prior to 1.14, timers were, I believe, a single kind of global timer queue. If you say sleep for a minute, sleep for 5 minutes, sleep for 10 minutes, they're always stored in kind of this sorted list. And you say, well, I'm going to sleep until the earliest timer, and then wake up and then go and kind of resort my list. I believe that this used to be a single queue, in the way that you have a kind of single scheduler run queue, which we turned into a per thread run queue many moons ago. The similar thing has happened to timers. There's now kind of the timers are shared amongst the threads running Go routines, and there's less kind of contention for. You can imagine if you have this big long list of all the timers, and especially if there are many of them, because everyone hopefully is using timeouts when you're making your network requests. They're usually with very small, like 30 seconds, 15 seconds, something like that. So if you're making 1,000 network calls, all that have a timeout about 15 seconds away, you can imagine that sorting that list is quite intensive. There was a presentation at GopherCon last year, which I might link to, but I think it kind of talks about a lot of this stuff kind of in the future rather than in the past. So when there are better things to, better examples here, I'll link to them. But again, for just regular workaday gophers like us, all these things just got more efficient, which is great because you really should be calling this a lot. This is an important function. Okay, some examples. What's happening in the standard library. This is a change that Roger Pepe alerted me to. If you use the standard template library, it comes with an EQ function, but its notion of equality was pretty limited. It was really, it could tell the difference between, it could tell you, well, the unsigned int1 and the signed int1 are the same. But in terms of comparing anything more complicated, it was much more picky. And there's a link at the bottom here. There was a number of workarounds here, but suffice to say, in Go 1.13, you weren't even allowed to use equals on pointer type things. So forget about a pointer to a struct. In 1.14, that now works a lot better. It's just a nice kind of, like, we can see that A and B are pointers to N, and N never changes, so they should always be equal, both because they're the same address and the same value. So just a kind of quality of life type thing. This thing, map hash, entered Go 1.4, just slid in quietly. Honestly, I don't know why you need it. Like, it's another kind of hash, which is specifically for writing maps. You might, if you want to write your own hash map, it's how it works, but I honestly don't know why. Like, it's a collision resistant but not cryptographically secure. Like, why don't you just use SHA-1? I guess it's kind of like, it's a cheaper hash. So I think it's modeled on the hash function that we use for maps internally. It's not the same one, obviously. But I believe it's supposed to be, because it's not cryptographically secure, it's cheap to use. So if you're going to write your own hash map, now you have another bullet in your foot gun. Some good stuff that Filippo's been working. SSL v3, no more, thank God. Yes, as I say, it shall not be missed. Encoding JSON. I need to link to the issue here, but JSON.number, which is a type you can use on your JSON fields that, does anyone use it a lot? I think it lets you kind of, if you have things in your JSON that could be a string representing a number, a small int or a large int kind of thing like that, I think it's the type that works with that. Now it's a bit, it's pickier about invalid numbers, and I'll find the link to the bug. There was a large discussion about like what is the backwards compatibility impact of this. But yeah, I'll find a link to the bug. I'll post it here, and you should be aware of it. Math has support for fuse, multiply, accumulate. This is the one function that all machine learners basically just do constantly. You just call this over and over again. Yeah, so there's a set of functions similar to math.bits, which look like kind of very complicated functions to call, but actually compile down to a single machine instruction if you have it. Has anyone played with it? Looking directly at Chewy? Yep, so the GoNum folks have incorporated it. And the way that Go does this with intrinsics, it just looks like a regular function call, but if the compiler has for your architecture a specific instruction which does exactly the thing that you want, it's replaced by just that instruction. And it means that over time contributors like the PowerPC folks, the RISC-V folks can come along and they can replace that intrinsic of the Go code that would do the same thing with the actual instruction. So they get performance. And also there are some, part of the, I'm going to speak off the top of my head, but part of the problem with this multiply and this addition is the order in which you do them. Like it's very important that you do them in this order and they're not reordered because of the error that's accumulated in floating point numbers. So just again, another kind of quality of life thing. For all dozen of you in the room who are using FreeBSD, plugin support. Plugins really haven't changed very much in terms of the restriction of has to be compiled with exactly the right version. That's kind of nothing's really changed there, but FreeBSD now supports plugins. So this is an exciting thing that kind of. So we now have a method. The reason it's called TB, there's actually an interface called TB. I think it's testing.tb, which is the interface supertype for both testing.t and testing.b. So it's basically a way of saying that these functions exist on both. So here's a case. Like you want to like make a tempter for doing some kind of stuff with inside your test to make sure test the fatal. You have to make sure you move it at the end. If you wanted to wrap this up into a function, like you wanted to make this into a helper, how would you do it? Like the defer would run in the context of the helper and then delete the file immediately when it came back to the caller. The classic way is you kind of return an anonymous function and you defer calling the anonymous function. So it's kind of like you put this computation, you say do that later. Fortunately, we add t.cleanup and combine it with the awesomeness that is t.helper. Does anyone know what t.helper is? So t.helper just says ignore this in the stack frame. So when this fails, it actually reports this line as the one that failed. So again, if you're writing assertion helpers or check helpers or something like that, you don't get all your test failures as the same line that your helper is. It actually reports it on the line above where it fails. So we have a helper called tempter. It takes a testing.t. We just say, by the way, this is a helper. We do the same thing. We fail. If that happened, that'll report the error up here, by the way, not down here. And then we call t.cleanup, and we put that defer stuff in here. And you may probably be a little bit careful about actually calling this because I wrote this on the train, and I'm not sure if that's actually the right way to delete a temporary file. But you can see that we're putting this kind of code that we used to defer into this tcleanup function. And you can just keep stacking these up and keep registering them, and they're guaranteed to run when the test exits. Whether it fails, whether it succeeds, it's how you do your cleanup. And now you can write a nice little helper that just returns the thing you cared about and the registering of the temporary stuff to happen later is taken care of you. So that's a great kind of, I think the testing package has probably been the one that has reached the most kind of like, just no great kind of, no great leaps and bounds, but just over time has just improved in terms of its quality of life. skipf, t.helper, it always just keeps getting a little bit better over time. Another thing is that GoTest-v now streams its output. So if you have say you're trying to use the testing package for writing an integration test or something that does a lot of setup and a lot of teardown, like not looking at anybody in this room, but you're kind of like starting a Kubernetes API server in your test. Hey, don't joke. I used to start MongoDB inside our tests. There's no limit to the crimes. Now, testing.v already streams the actual test cases they run. So test A, test B, test C. Well, everyone knows that they move up the screen as they occur. But inside an actual test, we actually collect up all the output. And then if the test succeeds or generally if the test fails, that's when it is kind of burped onto the screen. So this change means that no longer that output is no longer buffered. So let's just quickly, the reason I wrote it like this is format to print line will always print directly to the screen. T.log is buffered. So that's the thing that changes. So in 1.13, we see as the test runs, like we get the run started, then we get 5 print lines, we get the pass, and then we get the 5 log lines. So this is beforehand, this is before. Now we can see that the output is interleaved because the t.log lines are being streamed out. And obviously you wouldn't call form to print line anyway, but I needed a way to show you on the screen rather than run the code directly. But any questions? That's pretty straightforward. Again, another, if you do a lot of logging, like if you're using GoTest for writing integration tests, and they take seconds or minutes, this is another quality of life improvement. So the last one. Performance. Yeah, like I used to work with a gentleman we called the Upgradatron because no matter what Apple released, he installed it instantaneously. I don't think he ever learned his lesson. But the main reason to upgrade, well, 2 reasons. One, the old stuff ain't supported anymore, and the other one is it should be faster. So are the binaries smaller? Nope. Not really. They are slightly smaller in tip, but no real change there. I don't really think anyone's... I think most of that work is happening in the linker branch, which I'll talk about at the end. But it certainly wasn't a focus for this release. Are compilations faster? Yes. Woohoo! That's like a minute 47 to a minute 38. Like that's, I don't know what that is in percentage-wise, but certainly like that's a good 10 seconds that you get back over a 100-second compilation. So that's pretty good. I mean, this is that's that same 50 meg binary which builds Kubernetes in the whole world. So, is it faster? A little bit. There are some wins here. There are some. It's important to not just look at these numbers without looking in terms of context to these ones. So, like the file catch change. Yes, it went up by 5%, but yeah, okay, that was like 2 seconds. But like some of the ones that go down, we're talking in the millisecond range. So it generally, every release of Go seems to get a little bit better. There are some standout ones, although honestly, if you're using Gob, like you've now got 16% improvement here. gzip's looking better. Some question marks for JSON decoding. So yeah, some wins and some losses. These weren't done very hermetically. These were just done on this laptop this afternoon. Yeah, so I tried to crowdsource this and try and get mainly the gentleman who used to post those lovely GC graphs has gone silent for the last couple of years. So I was trying to tease him out of the woodwork, but he didn't take the bait. But we did get some interesting. It's linked to the Twitter thread up there. Some improvements here, and like don't forget, you get these improvements just by recompiling your code. You don't need to do anything. You just get them, it's as close to free as it comes. Hugo benchmarks, yeah, another few percent there. Some losses. Peter, I think he's saying this is worse. I can't really figure out what he's actually measuring here. I seem to kind of blank whenever someone gives me a Grafana dashboard. It just kind of seems to like cause some kind of like lock up in my brain. The one kind of question mark there is ClassPost, who is all things compression in the Go world. Some pretty serious, pretty kind of serious regressions there. And we're looking there. I believe that they're looking at that now, so you can follow the link to that issue there. If I had to speculate, all of these wins and losses are to do with garbage collector improvements and the change to the allocator. I'm pretty sure that's where it's going with classes 1. Don't forget, most of this code has been optimized for the observed behavior of the way that the Go GC used to like to do things. And if it used to like to do things changes over time, there will be reactions, sometimes positive, sometimes not. So in conclusion, what's coming up in Go 115? Not a lot of details so far. I did do a quick comparison between the 114 numbers and tip just before. Very, very small change in there. Josh has been landing a lot of kind of clean up and improvements to the SSA compiler, which are like real tiny micro tweaks. And in terms of both compilation speed, memory used by the compiler, and the quality of the compiled code. A couple of weeks ago, the Go team posted a blog with their kind of proposals, like the kind of small things that, small kind of user-facing things that they're wanting to do. I've linked them there. String to int conversions in Go Vet. Again, another vet change. And this one, which was, unfortunately, I don't think is going to happen because they thought it was backwards compatible and it wasn't. Turned out to be. So, yeah. 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 So you can follow the links to all those. And the last one, I really hope will land because they've been carrying on this dev link branch for about 2 releases now, is an improved linker. Most of the goodness that can be got out of the Go compiler has kind of been happening. Like we parallelize compiling functions in parallel, we parallelize compiling packages in parallel, but there's this kind of elephant in the room, which is the linker. The linker is effectively a garbage collection cycle over all the binary files that you compiled, bring them together into one program. So remove duplicates that can happen through different kind of compilation paths, do a lot of fix-up, a lot of kind of work, as well as generate the reflection tables, all the source code links, all the stuff that we strip out of a binary and we do minus S. But the linker really hasn't changed until it was ported over from C in Go 1.4. So it hasn't really changed in 10 releases. And so there is an all-out effort mainly by Cherry and John in the Go dev.link branch, who are just pulling the whole thing apart and coming up with a more kind of newer linker from the start. In the same way that we threw out the old compiler and had this new SSA form in 1.6. So some stuff coming up. As always, great improvements, but kind of in our life, where as Go users, we're just used to kind of stay on the latest. And you kind of get all these goodness for free. I'm done here, but if there are any questions, you can talk to me in the break. I probably don't have the answers, but I can definitely point you to the person who does. So thank you very much. We'll hand it back to Chewy.
All right, so catch Dave at the break. We'll have a 10-15-minute break. Eat more food because we seem to have overcatered. We had a lot more RSVPs. Anyway, but hey, that's COVID-19 for you. We'll be back in. We'll be back in 15 minutes. All right. Okay. Are we all ready? If we're all ready, we could get all take a seat. Our next session is about the stars. There's plenty of food that you can get after Kelsey's talk, I guess. But everyone here knows Kubernetes, yeah? Heard of it, yeah? But that's where the word cyber came from. Um, yeah, cybernetics, yeah. Yeah, true, fair enough. Sorry? Control. Oh, well, I'm not sure. Anyways, so I have a confession, right? I built machine learning models. I built them in a single binary. I put them in the cloud by SSHing and copying it into there and just running it in the cloud. Didn't know much about Kubernetes until very much recently, and I followed Kelsey's Learn Kubernetes the hard way, and it was quite interesting. Anyways, I am rambling. I would like to introduce, well, I don't have to introduce Kelsey Hightower because everyone knows him and no code. So take it away, Kelsey. Kelsey.
I'm in Sydney, finally. I came to Australia for, oh yeah, you're happy. It's a long gas flight. Yeah, it doesn't look that long. You're like, I'm gonna get there when? 2 days into the future. Before I start, there's like something that interesting, like if you've been around for a while, technologies come and go, and the ones that stick, they're typically fortunate to have a great community behind them. There are people who produce a lot of code and tools that are usable, and more importantly, there are a subset of those people who produce knowledge for a lot of other people to actually ramp up and produce the next wave of those things. And Dave Cheney, where's he at? Where's Dave Cheney? Did he leave? Dave Cheney is one of those people in the Go community. So if you've done something or learned something from Dave Cheney, make some noise and we'll say it was for him. So I'm going to be talking about random stuff today. It's a meetup. I afford myself some randomness. Is that okay with you all? Yeah. Great. So I came here via the airport, okay? And I was working on a project. And it was some patient service thing. So, and it needed some HIPAA compliance. I was looking at some of the requirements. Like it needs to be HIPAA compliant. I was like, damn, I don't have a lot of time because this thing needs to be done by Friday. So I'm walking through the airport, and there's this this big box of USB keys, okay? And in there, they had all of this like code that's ready to use, like super secure software. And on the sign, it said free software. I was like, sweet, I have a chance now get this project done on time. So I take one of the USB keys, and I did something really smart. I put it in my laptop. And there was a folder in there called HIPAA. I was like, oh, hell yeah. That's what I need. I need to be HIPAA compliant. So I looked at the name of it. It looked legit. And the other thing you got to do, too, you just don't use source code that you find, okay? That's pretty dangerous. This is how I've seen developers do this. I'm like, how do you know it's legit? They're like, to be honest, man, what I do is I do this. They do this move. You ever seen someone do this? It's like, hey man, there's GoDoc, it's legit. I was like, that's not enough, bro. But again, you have this Friday deadline, so you don't have time to waste. You got to get this to production. So the thing you should do is you import the source code right here, bam. So I import this HIPAA code, and at the bottom it has a really healthy function that says secure, listen, and serve. So I was like, sweet, that was the last piece I needed to secure my app. And a lot of people here are like, you're an idiot. You found a USB key at the airport. You stuck it in your laptop and you imported your code and deploy it. Who does that, right? Like in your right mind, who does that? And I think about it, and it's like every developer in the world does something equivalent. You're looking for some project. You go to GitHub, it's like, oh, that person looks happy. You take the library and you import it into your application and you deploy straight into production. There is a serious problem with the way we've been doing this software for the last 10, 20 years. Most people have no idea how bad this is. So let's take a look at what we've enabled here. So if you look at this like Go module thing, right, it has its pros and its cons. But one of them is that, you can track some of these dependencies. So when people's like, oh, your app doesn't have a lot of dependencies here. Right, you import this HIPAA thing, it does the thing. How many people read the source code of all of their libraries? Raise your hand. You're lying. So we literally are walking around the airport, finding random ass USB keys, downloading them into our secure network. Your InfoSec team bought a lot of security products. And you just said, forget it. So you look at this, like, what dependencies does this have? How many people look at the GoSum? So you look at this thing. I'm like, that's a lot of extra dependencies. What is all of this? Why is gRPC here? What does gRPC have to do with listen and serve? Anyone ever see that? Does this freak you all out? What do? You deploy it to production. You don't care. It's like, hey, those are probably all legit. Sometimes I'll scroll through there. I have no idea. App Engine? I'm not using App Engine. Why is it here? I actually don't know what's in this. I know Mitchell Hashimoto. He's at HashiCorp. He's legit. So the proposed solution to this problem, we won't talk about the 100% solution yet. Does anyone have a solution to this problem? What's that? Sonatype, proxies, all of this? I don't think it will help you. Because the attack vector here is, let's say I make a really good JSON or YAML parser. I'm a good citizen for 4 years. Most people are using CI/CD systems. There's a new version available. It's backwards compatible. You're just going to suck it in as fast as you can. So if I'm patient, you will gain a lot of trust. My reputation will become high. There's nothing wrong with this package. There's no security. And most of the security vendors you're paying are not also reading the source code either. They're not even reading it either, because how many people would you employ to read every line of source code in all the repositories? So we know it's not happening. So we bring it in anyway. And then I decide in 4 years that I no longer care about that repository. Do you know what typically happens with most source code repositories? We turn it over to the first person that looks like it may maintain it. We just say, hey, you seem to know how to write Go. I've never met you before, so you can have commit access to the repo. Now this person is borrowing my trust. One change, who do you blame? Is it my responsibility? Because you don't pay me anything. Who's liable for this one? So one thing people thought was a solution, this Docker thing. We're going to put it in a container. I was like, why is this a solution? What do you believe this is going to help the problem statement? And the reason why this is hilarious to me is because I'll meet with a lot of people and they'll say, what's your container security story? I was like, you're missing the problem. You can lock down all the ports you want. You can have the securest cluster that you want. I'm going to attack you on what port? 443. The only one that's open. And I'm in memory. So we have a responsibility here. So it's not a container is probably not going to help you. So people are pushing these containers to these registries, and they're buying a lot of stuff. And the containers are scanning all of these things and finding random ass vulnerabilities. And the security posture these days, red is bad, right? Red is bad. Make them turn green by all means necessary. How do you make these turn green?
Update the dependencies.
update some random dependencies that you don't know why are there. And you just like, yum, update. Am I right? Like, I remember Heartbleed came out, everybody panicked. They even came up with a nice logo for it, looked really good. So that means someone hired a graphic designer to make a logo and published and say, hey, here's this problem. And everyone ran and did this rush. And remember, Debian was like, hey, here's our package. Maybe it was another distro. And they said, you should patch immediately. And then people patched everything. They said, our bad, the patch is worse than the other thing. So everyone's like, what should I do? I can't trust you anymore. But you just run yum update. So people in our industry, for the most part, are just running updaters to make these things turn a different color. We have no idea why. We don't stop there, though. We will make all these things turn green. And then we will bring in another project, because obviously that's not enough. So we bring in something like Istio. And we build a fort around 443, just in case you get any ideas of attacking another fort or another port. So we build in all these service controls, and this stuff is quite helpful, right? You want to kind of limit your dependencies, or you want to limit some of your security vulnerabilities. So we bring in all this other infrastructure, ignoring the fact that 443 is still our problem, but it's susceptible. People will bring in all of this infrastructure. How many people know what Istio is? Have you seen it? Raise your hand if you have not seen Istio. I'm going to show you the false security model that people have in their mind. I have a very simple service. Let me see if everything is working. I'm tethered to my phone, so I'm hoping it's going to work. So in the industry right now, the status quo is not necessarily fixing this source code problem. We're trying to fix the world around it. So there's two things at play here. One is people are trying to create some secure infrastructure, right? So when you read the Get Started world, people always want things to be easy, okay? So when you want things to be easy, people say, Kelsey, I want a cluster in 5 minutes, complexity, something, something, complexity. I don't like complexity. I don't even read my source code, by the way. So you got 3 minutes to give me an enterprise-ready cluster. I'm like, enterprise-ready, 3 minutes, yeah, okay. So you run this command and you get a cluster. And you do the responsible thing is you take that source code and you deploy it to this cluster. And then someone says, well, Kelsey, how do you make a secure cluster? How many flags do you think we need to add to this to make it secure? I know most people are like, I don't give a damn, man. Like if it starts up, we're good. So we look at the thing you got to do to make this secure. Very obvious what this stuff means. Anybody know what shielded nodes are? Shielded sounds secure, doesn't it, right? Like you put it. If you see someone walking around with a shield on, it's like this person is probably not the one you want to mess with. First of all, they have a shield. And the name is not Zelda, so there's a problem. There's other stuff for security here, but these are all the other things that you need to do. And on top of that, if you really want to have some good multi-tenancy, then you need to use tools like gvisor inside of a sandbox for secure boot. There's a lot that goes into securing the platforms. Are we still secure? Are we secure now? 443. What's that? Yeah, you can put let's encrypt, so the hacker is now encrypted. Yeah. Even better. This makes it worse. It's like, hey, you're about to rob me. Here's this invisible cloak. Damn. It is now worse than I thought it was. This is essentially what we're doing. So we're still not secure here, but we can't stop here. How many people are practicing DevOps? You go to the DevOps meeting, because they have these DevOps meetings. Yeah. You've been to the DevOps meeting? Have you ever sent an email with the word DevOps in it? Yeah, you did.
I have been in DevOps teams.
Okay. So you go to a DevOps meeting, and they spend a lot of time on this. Am I telling the truth? Am I telling the truth? I am. And you're sitting there as a developer, it's like, when are we going to talk about the source code? It's like, it doesn't matter. We're going to do this part. I'm going to put it in Terraform. So 7 years later, everything's in Terraform. And you're asking yourself, should you say something? But we can't stop there. So now we need to bring in some more infrastructure. And Istio is actually pretty nice, by the way. I actually recommend it. Security in depth. But don't worry about 443 yet. Suspend your belief. So we need to bring this in. So how does this work? So you bring this in because people are saying, hey, we don't know what the app is doing, so we're going to limit our blast radius in a way that's consistent across all languages. Okay? Go being my favorite, but it turns out there are some people who write code in other languages. So we want to make this thing secure. So the one way we can do this is if we deploy apps, I have an app here. Let's see if I can remember the command. So if I call this command, it's an API call, and it should get my dependencies for a particular app. Let's see if my tethering works. There you go. All right, so let me show you how this works. So I have an API, there's a front door, and when you call it, I have a front-end API that calls a back-end call calculate. You can do add, subtract, whatever. It's a very simple app. And the thing is, we don't know what's in those. So I've worked in ops before being a developer, and the truth is, I actually didn't care what was in the app. My job was to get it deployed, because I assumed you knew what was in the app. I spent a long time as a sysad man assuming that developers actually knew what was in the app. It took me 7 or 8 years to realize that this wasn't true. But here's why we still have this conversation. So I'm looking at this and says, hey, I want to limit what your app can do. So tools like Istio help. Here's how they help. I want you to be aware because I wanted to show you the gaps in some of our security solutions so you understand that responsibility is yours. But we got to go further because the industry is spending a lot of money in these areas, and it's super important. So we have this app. Every security person's dream is to be able to do, I'm going to show you. This is a security people's dream. Everyone in security dreams of a world where they can deny everything. You ever met InfoSec people? How about we just turn it all off? All of it? Yeah, then it'll be secure. It's like, so we can't do that actually. But this is like the holy grail policy. Anyone know why that deny all is such an important policy? It's probably the best starting point you can ever have because now you have to do the hard work of explicitly adding everything else. And why don't we do it? First of all, most people don't know how the thing works already. So putting this in place, it's just going to all break. So the first thing you do when it breaks, you delete the rule and say, hey, it was working before. Okay. But this is the starting point. So I actually have this policy in place. It starts there. But how did my API actually work? So we have to do a few things. The next thing is we need to be very explicit about what's happening. So for example, all the clients that want to talk to the calculator service, when you're using something like Istio, you can give these authorization policies. And I'm going to talk about how this gets enforced. But we want to start to have a discussion around what is our security posture. So what this reads is, hey, we have an authorization policy. And any app that has this service account, so the API is my front end, and when it gets deployed in my cluster, it's going to be presented cluster.local, namespace equals default, service account is called API. Okay? Now, one thing we can do is since we don't want to necessarily change the code, there'll be Envoy. There's a little sidecar proxy. So when you hear about Istio, it's always in this form of a extra proxy on the outside of your app, hijacking all your traffic, both inside and out. So what will happen is that proxy will use this service account and as a JOT token in the header when it's talking to any other app. So that means we can start to enforce these policies whether the developer does anything or not. So here we say anyone that is in the API can make calls to the calculator app that can only do these methods. Okay? Now the whole point of this is that we want to build a zero trust network. Can't trust anyone. Because we don't know if people are reading dependencies or not. So I can't trust you. Whether you're a bad actor or not, there's just no reason to trust you. So what we do, we try to get explicit as possible to reduce our blast radius. So if you compromise the app that's running, the only things that can call are these endpoints. At least I know I can limit what you can do. So this is why the industry is spending so much time around the application layer, because it's the last defense most of us have without necessarily resorting to this final problem. So with this in place, I'm going to show you what happens when you remove it. If I say kubectl git pods, I'm going to switch to the right cluster if I'm not there yet. And I'm going to show you what this actually does in an automated fashion. All right, so we have the calculator, we have all these things. There's really only one container in my deployment object that I specified, and the cluster is adding the sidecar. This is why we have two containers in here. So one is the developer app, the other one is the Envoy proxy. So in this case, what I'm going to do now is delete this policy. So I'll say kubectl delete -f authorization policy, and then we'll just do the calculator client. So we're not rewriting the code. We're not asking the developer to do anything the right way. We just have the infrastructure around it to try to protect what we can. So now what we'll do is we'll run that command again. See, we have our curl command. Someone knows where it is? Like Kelsey used the history command? Not there? Okay. So if we run this, now this is breaking because I'm not handling the error correctly. But if I were to look at the log files here on this app, you can tell that now the connection is broken and we're not getting the JSON response back to marshal it, to return it to the output. So I'm just getting this error now. Now, an operator that doesn't know how the app works, I get to control the app from the outside. No recompile necessary. I don't have to trust what's in there. I control with these policies. So if I want to put this back, that whole client thing that we were just looking at again, I can deploy, I can have a fleet-wide, so we're deny all, so everything is broken. And now what we can do is we can put the client calculator back. So what will happen is, it'll go to the central control plane. This rule will be calculated, and then it will be sent down to all those sidecars so that every app will have the right policies. And it takes a little while before it to sync up. And then we'll just do a watch here, and let's see how long. That's not what I wanted to do. There we go. So now it's working. So a lot of the industry has given up hope or has lost hope in ever fixing this at the app layer. We believe now our only line of defense is to have things like Istio and Kubernetes providing these layers underneath. The last thing that we get from this declarative model is this one. I'll show it to you. So once we have everything declared this way, now we can actually study this thing. So I'll run this dashboard, and it's going to be aware of all of my policies that are currently in place. And ideally, what I'll do is have the ability to validate this across all the apps and services running. And the last thing to think about here, though, is once I have all this metadata, I was getting errors earlier from removing that policy. This will converge in a moment. But you can now actually see that the whole policy engine, all the declarative flows, at least lets me answer the questions, what the hell is running, and what is it talking to? The last mile of this, though, is you can see it cleared up now because there are no more errors in the system. Now that we have this amount of probing and protection around the application, we can actually secure things at this level. The only thing missing in the industry now is the port 443 problem. Until we close that particular door, none of this innovation will particularly matter going forward. All we have now is reputation. So if you produce a library, you have to start thinking about how do you publish CVEs, how do you even check for them, how do you do reporting, and maybe the first step we will get is reputation. Anyone know what I mean by reputation when I'm talking about in security? So think about cars. They have cars in Australia. They drive on the other side. And they have VIN numbers. So in the US, you have this ID. This is your VIN number. Now, if a car manufacturer produces a car with a faulty airbag, the first person to find out that there's a faulty airbag, it's not going to be a good time for that person. This is bad. It's not that we can prevent this from happening. But now what we can do is we can send out a recall. We know every person that has a faulty airbag based on this VIN number and the IDs of every part that's in the car, end-to-end supply chain. So at some point, I believe that the way we do Go modules, the way we do checksums, is going to lead to reputation and being able to trace back software from the thing you have deployed. So instead of just a container image, I should be able to say that this image has this checksum of all of these libraries, and if there's any vulnerability that we find, we can at least notify everyone by saying, hey, the thing you're running, you have this thing. It's not going to be like we do with RPMs. It's going to have to be a slightly different system because we're not using traditional package management for the third-party libraries that we're pulling from GitHub, right? We don't have that consistent interface. So I believe that's going to be one of the challenges going forward. So this is a space that I'm spending a lot of time in. As developers of this source code, is it our responsibility to figure out how to close the front door, okay? I have a lot more time left, and I want to leave it for Q&A. I don't get to Australia very often. And I'd probably work with some of you online or maybe have built some things that you're interested in. I'm going to leave the rest of my time for questions, but for this part, that's all, and thank you.
Questions?
So the questions can be about anything, Go-related, Kubernetes-related, industry-related. It's up to you.
Anyone? Yes.
So you talked about the reputation, but is there like centralized, I mean, how do you measure that of, say, any previous thing you are going to use that?
So this is a good question. So you talked about reputation. Is there a centralized way to solve this problem? So Microsoft owns GitHub. GitHub is making a first stab at this, right? They're introducing a lot of these tools that are now doing, whether it's static analysis, using various security tools to check all of these things, and then trying to find all the other places where it lives. The problem with source code is that not everyone is importing modules. Sometimes there's a copy and paste that's happening, where you extract the function and you throw it in your code. You are still vulnerable. So we have to actually scan all the source trees to do this. So GitHub, I think, has a nice strategic advantage of having all the source code in one place. They can actually crawl the entire source trees for everyone and give you some heads up in your repo. Maybe there's a flag, maybe it automates an open issue. Here's the thing, if we know that we're seeing a lot of issues from a particular repository, then the reputation of that particular repository goes down. So today it's mostly stars. Hey, it looks like it has a bunch of stars, and we decide, and we do this mentally, there's a lot of stars on this repo, it must be good. There's a lot of commits recently, it must be good. You start to trust the people involved with it, but at some point, security is going to have to be part of that overall reputation. So we already have a system like that. Today it's GitHub for most people. You trust it based on the attributes we talked about, but at some point, I think the security posture would become as invaluable as those stars, right? So I think it's going to come in the form of the existing systems we have. We'll start to give you back some of those reputation points.
So will things like Athens help?
Things like Athens help. So I think that's one part of it. So we need to know what it is, right? But that's if people are using modules. So, Athens, this idea of caching, don't make it easy to delete these things, using checksums and not just the tag that people are deploying. So we need to get to a better place where Kubernetes and containers in general have started to use the checksum and not the tag to identify a version. So having something like this proxies that we're building where we start to say, hey, even though that says 1.0, it really has this checksum. There's no way we're going to give you a new 1.0 that violates that particular trust. So yeah, that's going to be a critical component, but it's one of the pieces in the entire pipeline required to solve this problem deeply.
Any questions? Oh, yes.
Hi. Yeah, I was just curious about with Istio. I mean, I work at a place where still trying to move away from OpenVZ containers, and there's still LXC, Docker Swarm. Think about moving to Kubernetes, but one of the things we were I was always curious about is, having worked a little bit with Istio, do you feel that some of the things in Istio should be part of just Kubernetes, or do you see them as two different, separate kind of things?
Very interesting question here. So the question basically is, you have this Kubernetes thing, it's a control plane. It has all these first-class APIs for deploying containers and workloads. 5 years later, Istio comes out. And it adopts the Kubernetes API, so it looks very similar. And it seems to pick up where Kubernetes leaves off, right? Kubernetes has built-in, what I consider Kubernetes has a built-in service mesh. There's IP tables, and you can create services, and those services get plumbed through in an automatic fashion, and then your sidecar happens to just be IP tables. You make a call out, it intercepts traffic, and it tries to load balance things for you. It's not a very powerful service mesh, but it has a lot of the fundamentals of things you think in a service mesh. Istio comes out, or Envoy comes out, and proves itself to be a very viable data plane, mainly for HTTP services, even though people use it for other things. The problem is, though, is it doesn't do everything, right? So if you have like some custom protocol or UDP, or even things that Nginx does pretty performant, like send file integration, Envoy isn't the best at that. So it can't solve every single problem. But when you look at what it's trying to solve, it does it in a pretty heavy way. One proxy per container. That's not cheap. So the kernel calls in that is like, you know, you go out your app to the kernel through Envoy, back again, and then back out. That's a lot of zigzag just to talk to another service. So I don't know if people will take that trade-off as a default being inside, but I think we are going to move into a world is if Kubernetes was out, or Envoy was out 5 years ago, and we had the Istio model, I think we would have probably done that instead of IP tables. That's my guess. We probably would have never had the Ingress API as it stands, and service discovery would have been a little bit more powerful because I think Envoy is probably the best place to do this client-side load balancing. Now, what is happening, Tim Hawkins is working on progressing to adopt and learn from Istio and moving some of those into Ingress v2, right? How can we learn some things from Istio and move it directly in? But I don't think we will ever have the full service mesh there.
Thanks.
If you ask a question as well, you get a Kubernetes t-shirt.
Oh, you're giving out
Google
Kubernetes
Cloud on the
t-shirts.
back as well, so
They're
you
clean,
can start
too.
asking some questions.
And I know you guys are running out of toilet paper, so if you don't like
Yeah. Next question.
You get a t-shirt.
Here you go.
You're showing a very simple microservices architecture here, but recently you've made some comments about back to monoliths. What can you expand a little bit on that, please?
Oh my goodness, I caught a lot of flack for this 3 years ago. I'm going to show you the tweet in question. Twitter gets you in trouble, folks. Yeah, so just like in 2017, and people's like, how can you say this? There's this thing we say, best practice. And I always say, for who? Everybody just practicing. That's it. I have not seen a best practice that uniformly works for everybody. Don't be an asshole is probably one. But other than that, most stuff is just practicing. You just got to have context. So when I meet a lot of customers, they're like, we're doing microservices. I'm like, why? What they want to say is, look, I went to a conference, and people had some really nice graphs, and I looked at my graph. Because, like, for example, let's say my company was making $1 billion with this graph. I'm killing it. $1 billion with 2 services? Genius. Not in our industry. That should be like a graph where you can't even see the edges anymore. Because we're competing with each other. You know, you sit in you go to the conference, you're sitting in a circle. It's like, yeah, we got 38 microservices. Like, we have 7,234. Damn, I need more microservices.
Except everyone's lying.
This is true. Oh, I'm going to show you. So here's the thing. Oh, I have a story. When I was a kid, I went to see this movie. Anyone ever seen this movie?
Yep.
All right, really, really quickly, what's the plot?
At the end, nothing's happened at all.
You don't know the plot, but we do remember the technology, don't we? You remember the DeLorean? The auto lace-up shoes, the flux capacitor? Everybody remembers the technology. No plot. That's how most conferences are. Right? You see someone on stage like, why are you doing that? I don't know, man. We just started and we never stopped. So you go to the conference and you see this keynote. So when I was a kid, you go to the movie. You notice the movie poster? So back then, it's like, I don't know, 1990 or something. and we had video stores. You go in and you rent the video, and you can rent the Nintendo game. So that was a thing. Popular movies, remember, had the Nintendo game. So you're like, oh my God, I just saw this movie, game changer. So you go, and remember, the cars are flying, shoes are lacing up. The best graphics you've ever seen. So you get your Nintendo, and you rent the game, right? So you're going to the video store, you're browsing all the games, and then you find Back to the Future. You're just like, oh my God, it looks just like the movie poster, okay? So you click on it, you go home, and you blow into the cartridge. I'm not sure why, it doesn't actually help, but you blow in it, and then you stick it in your console. Wait, this don't look like the movie. We're gonna get to the flying car at some point. Turns out you're no good at the game. You don't even know how to play. You just thought that doing the same thing that other people are doing was going to be this big, exciting thing you saw on the keynote stage, but it turns out to be true. So this microservices thing, what I'm watching people do is they take a thing that works. And in one of these boxes, there's this phrase. I'm gonna find it. It's one of my favorite tweets. It's on here. Oh, here we go. Sorry, marketing team. Keep fixing it until it's broken. So you go and I say, and I was challenging the customer, I said, how many microservices are you going to create? And they were like, we should say a big number because it's Kelsey. And the person said like 38 or something. I was like, why 38? He's like, I know it, man, 52. So then the Istio team, just a couple of days ago, no lie. So Istio was designed, let me not misspeak. We gotta make sure we go to the website, because you should only tell the truth in these things. Istio, so remember, and this is not a knock against Istio, we're just dealing with reality, right? So connect, secure, control, and observe services. This thing was literally built to solve the microservices problem, right? So on Twitter, let me find it. I'm not really that great at Twitter, actually. So if you see me being slow here, I'm gonna find it. Here we go. So this thing happened. The Istio project just consolidated its control plane and services, Pilot, Citadel, Galley, and the sidecar injector into a single binary. The thing built for microservices. And they wrote a blog post that they were embracing the monolith. Look, we had this complex, hard to debug, hard to troubleshoot, and now we have this. So if you're a developer, you're like, hey man, the thing that helped me with microservices is going back to monoliths. Why are they doing this? And the reason is probably the same reason that most companies are doing it wrong. And I think people got confused along the way. I remember the whole idea of services architecture was not about how many binaries you can create. If you're in the Java world, it's about the number of war files you can deploy to JBoss, but it's slightly different. We're supposed to make modular code. And based on the modular code, we can compose it however we want. Maybe you do it at your import statements and you compose in function main. There's 1,000 ways for you to connect those services together. It didn't mean that we go and create a dedicated binary for each of them and then glue it all back together with JSON, TLS certificates, Istio, Kubernetes. Like you spend more money, like people are spending 80% of their compute budget gluing back together the monolith. So when they say, Kelsey, how would you fix the performance here? I was like, you're not gonna believe this, man. Have you tried the monolith? And they put it back together. It's like, dude, we just saved 80% in performance. Now, the last thing here is, when should you do a microservice? So I worked in finance and enterprise, and you have this big monolith that just grew that way. It's not designed that way. It usually grows that way. And there's a new thing that comes out. Maybe we want to do mobile, or maybe we have a new client that comes online. And it's fairly isolated concern. We used to process a lot of batch files. The file will get uploaded, you will pull the file, you process it, and then you're done. That's all this thing did. okay, you can actually make another binary just for that thing and just run it. There's no need to stuff it in the monolith, listening to some new message queue that has nothing to do with the monolith. And I think that's okay, and that's an organic way of adopting microservices. But this whole carve up the monolith, I have not seen a lot of companies ever do it successful. How many people have ever done this successfully? Not a single hand in a room for developers, and this has been hyped up for like 20 years. So that should tell you something, that now we need to do a retrospective as an industry. Were we really wrong about this microservices thing? And if we were, what went wrong? That's a great question, by the way.
All right. Any other questions?
We're up here.
Oh, sorry.
Thanks for your talk about the security. It's been a problem people have been talking about for a while, and I mean, yeah, your example of someone gaining control over a byte stream library and then committing a very convoluted attack against a cryptocurrency wallet, right? But without your point, without reading the source code, how can we be sure that this isn't going to happen to us? And for example, the reputation thing, it still doesn't solve the core problem. Do you have any ideas on how we can
I
solve?
was reading a report, and I didn't have time to validate it all, but they say most people takes them 4 to like 10, 12 months to find out that they've already have someone in their network. Like, you just can't have this be a year. Right? I think there was a public release. I don't want to, call them out too much, but like Citrix sells security products. There was a public post that the FBI had to tell them that there was someone in their network after for 4 months. So FBI is like, man, do they know what's happening? I don't think they do, man. It's been 4 months. How about we tell them now? This can't happen. So yeah, you're right. We can't necessarily prevent these things, but you want to be able to let people know, like, this thing is happening, and you want to be able to notify people that they have a problem and they should do something about it. At some point, then liability will follow. So once you start to understand what's happening, then we're going to have a conversation at some point around liability. Should there be a responsibility? If you build a building and people move in and the building falls on them, is there someone that's liable? In software, we're like, dude, free software, man. You can't build a building for free, and this is the tricky bit about software. We all think it's free. Those keystrokes that we're doing in the middle of the night, we don't think about the time that we trade off to do that kind of work. This is very malleable, it's very easy to ship, and it's very easy to adopt. So you're right, we don't think about it in the physical sense. But at some point, though, there is a liability component to when these things go wrong. And right now, we haven't got around to that maturity level quite yet in our industry, right? Unless you sign a contract for someone to take on that responsibility. We got to figure that out at some point, or someone else will. So this is why I'm kind of talking about this thing and working on these kind of solutions internally, because at some point, do you want someone to tell us and regulate our own industry around software and free software, or do we step up to the plate and try to figure this out as well? All right, any more questions?
Somebody on the left-hand side of the room, surely.
All right, one back there.
I know that right.
You can ask about no code, and then we'll wrap it up.
In a related thread, but I guess a bit slightly more abstract, I believe Robert Martin mentioned recently about the future of the software engineer, where we call ourselves engineers, but we don't hold ourselves to the same standards like professional registration and effectively on paper taking responsibility for the products we put out there. I think the 737 MAX 8 thing was a great example of that. What do you think the way forward is for that?
So there's a couple of things. One thing that I like about the software industry, I have no college degree, no college experience. And we have one industry that pays well. You can create important things in the world, and we don't have a lot of gatekeeping. There's a lot of engineering fields that are not open to everyone. They can't even use the tools because you have to be certified to even buy certain tools. Our industry isn't like that. I don't want to see that from our industry. So the gatekeeping talk, I'm not a fan of. This idea that someone gets to tell who gets to write code or not. So that's a separate discussion. But as a professional, these things fall on us. So I think there's a bit of empathy we got to have for what we're producing, whether it's the ethics behind it, whether we think about what's happening with the code once we ship it, and who's responsible end to end for this. And I think that's the part where as an individual developer, I think about these things, right? Now these days when I write code, I don't necessarily think this whole code reuse thing is panning out the way people thought. For example, I have this Cloud Run library. So I work at Google, and I really, really like the team, and I trust a lot what they do. But again, I'm trying to be super responsible. So I'm going to show you some of the measures that I've taken when it comes to this dependency business. Importing a bunch of packages, I'm just not a fan as much anymore. So personal responsibility, I'm writing this for Cloud Run, our serverless thing based on containers. And when I'm writing this, I ask myself, do I really need to import all those libraries? It turns out that I can integrate with every GCP service in about 300 lines of code with no third-party dependency. If I were to import all the recommended libraries, this binary would probably be 25x the size. It'll go from 2 megs to like 35 megs as soon as I import all these random libraries, and now I have to try to pay attention to them all. So what I've done is I start to look at the code and say, I'm not going to start with importing a bunch of libraries. I'm going to figure out what code I actually need, and that's all that lands in my SDKs now. So when people import my third-party libraries, I'm trying to make sure that I'm doing a decent job of not bringing in unnecessary dependencies. And when Go first started, that was like one of the things we used to brag about. We've done this thing with no third-party dependencies. And I used to think people was like, oh, you're just reinventing the wheel. But the truth is they're trying to be responsible. What code do we need and where's that boundary? All right, so we're going to wrap up with one last thing. You keep asking me about no code, or someone asked me about no code. And no code actually is around this philosophy. How many people know what no code is?
Use it.
Oh, wow, you use it all the time. You should. Wow. Almost 40,000 stars. I'm proud of this one. All right, so this thing, I won't talk about too much of the origins of it, but this thing. So I'm sitting in the airport, my flight is delayed. I was gonna do this tweet about how I'm guilty of it as well. Sometimes we just start typing. Anything that comes in our head, we just start typing. It's like, what are you doing? Why are you writing all that code? So someone asked me, hey Kelsey, what is the best framework for like the best maintainable secure code you can ever do? And I was like, I got this framework called no code. And I was like, oh, sweet. And when I publish things, I like to write documentation for everything. So I'm gonna walk you through. So this is the best way to write secure and reliable applications. Write nothing, deploy anywhere, or deploy nowhere. So the first thing you gotta do, and a lot of people get this part wrong, so you gotta pay attention. When you open your editor, it needs to look like that, okay? That's how it's gotta look. Now here's the thing, if you do that, I know that's just an example, that's like my hello world, but let's say you need to add a few new features, right? Because hello world only gets you so far. And I really focused on like the developer UX when I did this. So to add new features, I want to make it super simple. So you can just add as much features as you want, doesn't take too much time. So the possibilities are endless. Now you got to build the application. Because you did all this work, and you talked about Go compile times aren't as fast as they used to be. So I thought about that a lot, Dave. I was like, damn, what would Dave Cheney say about no code? So to build the app, I went one step further. You don't even have to do anything, Dave. And the compile times are as fast as you want them to be. It gets faster every release. That's it. So you should see the following output. If you see anything other than that, something is definitely wrong. So I'm in this whole Kubernetes world, so people are like, well, Kelsey, how are you going to deploy it? I was like, yeah. So by running the following command, you have to do a little bit of work here, but not much more than you did before. Okay? So there's not much here. So it's that simple, and all you have to do is this. I know, right? So here's the thing. People ask me how they contribute to this. It's like, dude, you literally don't. But people started contributing, like serious business. I was at work and someone sent me an email. It was a very professional email. It's like, hey, Kelsey, love what you do. Follow you on Twitter. But this no-code thing is distracting my whole team. They're in Slack sharing issues from no-code. I'm like, what are you talking about? And they asked me to take it down. I was like, no, I'm not taking it down. But some of the issues are crazy. Like, if you have a lot of time to waste. I did a release for this thing because you can't stop there. So there's actually a release. I support a lot of frameworks and languages. Now here's the thing. I'll let you do this Easter egg yourself. If you download this, you'll get something inside of it. There is something in there. So there is a no-code release, you can get it. And I've had really no true bugs, but people keep filing issues. I did merge one issue. Someone actually followed the contributor guide to the T. So for example, you need to make sure you have a good contribution guide because people need to know what the rules are. So I have one. All changes are welcome as long as no code is involved. If you run into any bugs, please file an issue and explain how that was even possible. One person actually, there was a bug in GitHub, and they created a blank issue with no code, and it was a valid pull request. And when I hit merge, nothing changed. And so there's 4 commits. And so you can't even see the commit anymore. So GitHub fixed the bug. But they left my issue open. So I have like the only issue with no title, no body, no code, but still a valid pull request. So there's history in here. There's other issues here. Why are there pull requests? Whatever. But I haven't read these in a long time, and then people are actually giving people advice and comments. Like, you see this one? I guess the bug is still there. You can actually open these things this way. And so, it's too big. You should go through here. There's going to be some legendary ones, but there was 2 legendary things that happened in the days ensuing the no code. And I'm going to tell you what the whole meaning of this thing is. In no code, so product hunt. This is like in the US, they, highlight startups. And they did a whole review on no code and published it. And another woman, there was a Medium post on no code. Let's see. Let me see if I can find the post. Oh, there's lots of them now. I can't, this is probably not the right one, but I read her post and it was super serious, like, hey, my team is having a difficult time revamping the new microservices architecture we have. And she's like, I found this no-code product, and just looking at the project for 5 seconds fixed everything. And I was like, damn, this is legendary. So this thing took off and became a meme of its own. It became the top 10, or actually the top 3 repositories 3 years ago. It's like the #1 in terms of stars, so stars mean nothing in GitHub world, in case you were curious. So what's the moral of the story of no code? Anyone want to guess? Really, the moral of the story is here is probably code is a liability. Right? The more you write, the higher the liability. And if you're an engineer, you should be thinking about, do you really need to write code to solve that problem? If your answer is always yes, I guarantee you're probably doing something wrong. There's probably something out there that already works or exists, or should probably never be written. And you can't get to that point until you start to think about software as a liability. It's not something that we want to keep adding to our stack because we have to maintain it and babysit it going forward. So that's the story behind no code. Thank you all for the Q&A. I appreciate it. Thank you.
Thank you, Kelsey. A bit of housekeeping. So you know that our caterer is run by refugees to Australia. They're Parliament and King, and there is a lot of leftovers. So if you have like containers, please take the food home. But if you do not have containers, Ravi is giving you some oil, so you can pack some food home. If you want food, just hang out till he comes here. He's about 3 minutes away. All right. Thank you.